When asked to add or subtract fractions, if they have common or the same denominators, the bottom numbers are the same, we just have to add the top or the numerators together and check whether we can simplify our resulting solution. Here, if I've got 1/5 plus 3/5, you can see here I've got 1/5 coloured in. If I'm adding on 3/5, altogether when I count that up I've got 4/5. And you can see that's the same as adding the numerators. 1 plus 3 is 4. So you can see how it happens graphically, and then mathematically the bottom number stays the same and the top number adds. For subtraction, if I've got 9 out of 15 and I take away 4, so if I take 4 of those away, what am I left with? I've got 5 out of those 15, and you can see 9 minus 4 is 5, the 15. You're still talking about 15ths. That needs to be simplified by dividing the top and bottom by the same number. In this case, the biggest number that goes into 5 and 15 is 5. So when you do that division, you get 1/3. If the bottom number, the denominator, is different on each fraction, well, we have to make them the same first. We can use this equivalent fraction idea where we multiply the top and bottom by the same number to turn it into a fraction where we can then add or subtract. So here, see the denominators are different. I make them to have the same denominator. Now, I've cut these into the same number of pieces. So now this time they're in 12ths. How did I choose the number 12? Well, 3 and 4 are both factors of 12. It's the smallest number that they multiply into. They both multiply into without, or divide it by, without any remainders. So 12 divided by 3 is 4. 12 divided by 4 is 3. So you can see here, from this 3 to get into to change it to the 12, I've multiplied by 4. Whatever you do to the bottom of a fraction, you do to the top. 4 times 2 is 8. Here, the 4 has been multiplied by 3 to get 12. So the top number, that 1, needs to be also multiplied by 3 to get the 3 here. 8 plus 3 is 11, so it's 11 out of 12. You can see that graphically that works out. If I've got this example, I actually only need to multiply the first part of the fraction to get it into 6, because I just need to double the top and bottom, and then I've got my 6th. You can see when you cut it into the pieces what it looks like. So if I've got 2 of those 6 and I take one of them away, I would only have 1 left. So if I took one of those away, I'd have 1 left. Here, the smallest number that a 5 and a 4 goes into is actually 20. So if I cut that up into pieces of 20, you can see the bottom number here, the 5 I've times by 4, so I need to times that 2 by 4 to get 8. Here I've times by 5, so I times the top by 5. When I add up the numerators, I get 8 plus 15 is 23, but 23 is over 20 is an improper fraction, so I need to change it to a mixed numeral. So how many 20s are in 23 is 1. My remainder of 3 goes above my 20. So for this, another example, I will probably just multiply the first one by 3 to turn that into 6. So 2 3s are 6. So I get 3 6 plus 1 6 is 4 6. But if I leave it in that form, it's not in simplified form, I won't get the full mark. So I need to divide the top and bottom by 2 to get 2/3. Another example, 3 and 5. The smallest number that 3 and 5 both go into is 15. So first number is times by 5. The second fraction is times by 3. That results in 10/15 minus 3/15, which gives us 7/15. That can't be simplified, so that's that answer is good enough. We need to use these kind of fractions in problems. So we need to be able to read a problem and work those out too. So if we have a case where some people are at a cinema and Miles sells 3/5 of all the tickets and Lisa sells 1/3, what fraction of the tickets are sold altogether? We just have to add that up, make them all over 15, and then you get your answer that way. So this one we've times by 3, this one we've times by 5, and then you result. So 14/15 have been sold. So what fraction has been sold by Camillus? That would be the remaining. So the whole total is 1 whole, or 15/15. So we take away what has been sold by Miles and Lisa, and we'll see that Camillus is the person here who was left over, had 1/15 left over. Sometimes when we're adding and subtracting with mixed numerals, it is easier to add or subtract the whole numbers first, depending on the question. So if I've got this question, all I need to do is say the 2 plus the 3 is 5, 7 plus 1 is 8 over the 9, because it's the common denominator. If I have this example, the 3 plus the 1 is 4, then adding up the other parts, I would get 6 out of 5. Now here I've got an improper fraction. I need to change that into mixed numerals. So it's like, how many 5s in 6s is 1, with a remainder of 1. Now I have to add again. So 4 plus 1 is 5, and I would have 5 and 1/5. For this example here, I can add the whole numbers to get my 3, but then this second part of the fraction, the 2/7 plus 1/3, I have to make them have a common denominator. So the smallest number that 7 and 3 goes into is 21. 7 3s are 21. So top and bottom times by 3, the first fraction, second one by 7, and you'll result in 2 3s are 6, and 1 7 is 7. Add them up, you get 13. So you get 3 and 13 out of 21. For this question here, if I did that, it's going to get tricky, because I'm going to have my 2/5 take away 4/5, and I start dealing with negative fractions. So what we usually do is, because this part that I'm taking away, and often this happens with take away, if the second fraction part is bigger, it's just easier to change them to improper fractions first and then convert them back at the end. So here you can see 5 times 3 is 15, plus 2 is 17. 5 times 1 is 5, plus 4 is 9. I do the subtraction of the numerators, so 17 minus 9 is 8, and then I change that back into mixed numerals. So how many 5s go into 8 is 1, with a remainder of 3. So writing that as 1 3/5.